This video is on conditional probability. The probability of an event is often affected by knowledge of relevant circumstances. So, for example, there was a 2018 Gallup poll that said 5% of American adults consider themselves to be vegetarian, and if we break that into age groups, 8% of adults between the ages of 18 and 34 identify as vegetarians, compared with 7% of adults ages 35 to 54, and 2% of adults 55 and older. So if we suppose that an American adult is randomly selected and we define these events, V is the event that an individual is vegetarian, M is the event that an individual is 18 to 34, and B is the event that that individual is 55 or older, then in general, the probability that the individual we randomly select is vegetarian is 5% or 0.05. But if you have more information, such as their age group, that affects the probability that the individual is a vegetarian. So the probability that the individual is vegetarian given M, that they are between the ages of 18 and 34, would be 0.08 or 8%, whereas the probability of V given B, the probability that they're vegetarian given that they're in the age range of being 55 or older, is 0.02. So just to look at this notation a little bit more, this probability of V/M, this is the probability of V given M. That's how that's read out loud. Probability of V vertical slash M. And similarly, this is the probability of V given B. So this is the probability that the person is vegetarian given that M is true, given that they're between that age range of 18 and 34, and the probability that the person is vegetarian given that B is true, given that that person was 55 or older. And just in general, we call this the probability of A given B. And so that's the conditional probability that A is true with the knowledge that B is true or has already occurred. So we have seen this notation before, and we saw it as part of the multiplication rule. So in the multiplication rule, we knew that the probability of A happening and then B happening, or of both A and B occurring, was equal to the probability of A times the probability that B occurs given that A has already occurred, or given that we know A is true. So that was the multiplication rule. And so we can use this algebraic expression to solve for the probability of B given A. So the probability of B given A, let's look at the probability of A and B is equal to probability of A times probability of B given A. Again, that's just something we already know. That's the multiplication rule. To solve for probability of B given A, we can divide both sides by probability of A. And so that gives us that the probability of B given A is by itself now over here, and that's equal to probability that both A and B are true divided by the probability of A. So that's a formula for the conditional probability, and let's write it. And so that is the probability of B given that A is true. So again, we call P of B given A, probability of B given A, the conditional probability that B occurs given that A has occurred with the knowledge that A has occurred, and that is the probability of both A and B occurring divided by probability that A has occurred. So let's take a look at an example. So suppose that we have an exam in a class and 75% of students passed the first exam in the class, 56% of the students passed the second exam in the class, and 48% of the students passed both the first and second exam. So given that a student passed the first test, what is the probability that they pass the second as well? So I will let you pause and think about that for a moment. Okay, let's give names to some of these events. So let's let F be passed first exam, and let's let S be passed second exam. Then we can assign some probabilities based on the problem above. The probability that F is true. So for a randomly selected student, 75% of them pass the first exam, so 0.75. Probability that S is true is 0.56. 56% of them passed the second exam. And then that 48%, that corresponds to the people that passed both exams. So that is probability of F and S is 0.48. So, okay, what were we looking for? This is what we already know. So what were we trying to find out? We want to find the probability that given the student passed the first test, what is the probability they pass the second as well? So we are looking for the probability that they pass the second test knowing that they passed the first test. And just in general, in terms of notation, this is always the thing you already know, and this is the probability you want to find. So the probability that they pass the second exam knowing that they already passed the first exam. So according to our formula, that is equal to the probability that they pass the second exam and the first exam, doesn't matter what order you write those two things in, divided by the probability of the second thing that they passed the first exam. And so that's 0.48 divided by 0.75. And if we calculate that out, we will get 0.64. So 0.64, a 64% chance that if they pass the first exam, they will pass the second exam as well, as compared to the general population, just 56% of all students pass the second exam. All right, let's take a look at another example. So let's look back at that same poll from 2018. And if you want to check it out, I'll link to a website in the Canvas page as well. There's some different demographics broken up in terms of different demographics identifying as vegetarian or not. But in this problem, 5% of Americans identify as vegetarians, as we said before, broken down by political group. 11% of self-identified liberals identify as vegetarian, compared with 2% of conservatives and 3% of moderates. In the survey of 1,033 adults, 371 of them identified as conservative, 367 as moderate, and 252 as liberal. 28 of the 1,033 respondents identified as liberal vegetarians. So, based on the statistics from this poll, if you randomly select an individual who is a vegetarian, what is the probability that they are liberal? So just like the problem above, there is some extra information here. You won't be using all of those numbers, so you'll have to think about what you need to use to find the probability that if you randomly select an individual who's vegetarian, what is the probability that they are also liberal? Okay, let's start by giving abbreviations for some of these events. Let's let V again be the event that the randomly selected individual is vegetarian. So individual is vegetarian, and L be the event that the individual is liberal or identifies as liberal. So in that case, what are we looking for? We are looking for if the person you randomly select is vegetarian, what is the probability that they are liberal? So this part is known and this is what we're trying to, whether they're liberal or not, is what we're trying to find the probability of. So in other words, we want to find the probability that they are liberal given that, knowing that they're vegetarian. We know just in terms of the formula that that's equal to the probability that both things are true, that they're liberal and vegetarian, divided by the second thing, the thing that we already know, the probability that they're vegetarian. So what do we have in here? We already know the bottom. We know that in general, the probability that any individual from this poll is vegetarian is 5% or 0.05. We still need to find the numerator, the probability that they're liberal and vegetarian. So we can look back up in this all this information that we have and see that, among other things, 28% of the respondents identified as liberal vegetarians. Sorry, not 28%, but 28 of them. So those are people who were both liberal and vegetarian. That means that the probability that somebody's liberal and vegetarian is 28 out of the 1,033 respondents. So if we divide, we get a probability of 0.0271. And so that's 0.0271 that goes in right there. So this was sort of a calculation off to the side. And continuing, we can now divide 0.0271 by 0.05. And if we do that division, we'll get 0.542. So if we randomly select an individual and we kind of assume that this study is relatively accurate, if we already know that they're vegetarian, the probability that that person also identifies as liberal is 0.542, or a little over 50%. Let's take a look at a couple other of the pieces of information here, because there was a lot of info and you might have wondered, what numbers do I use and what don't I use? Another piece of information is, for example, 11% of self-identified liberals identify as vegetarian. What does that correspond to? So that is actually the probability that somebody is vegetarian given that they're liberal. So among those people who are liberal, 11% or 0.11 were also vegetarian. So that's what that 11% corresponds to, for example. And another thing you might have thought to use would be, say, the number of people who happen to be liberal in this survey. That would just be P of L in this survey. So 252 people in the survey out of the 1033 identified as liberal. And so that would be 0.2439, which we didn't happen to need to use for this problem. So it was just extra information in this case.